Thanks for finding your way over to the remote facility. My name's Jeff Williams. This is Arshan Dabirziagi. And today we're going to talk about some of the security research we've done using the Java Instrumentation API to enable automated vulnerability detection in Java EE apps. So we think we've made a pretty interesting breakthrough here, and we're really excited to share it with you. So you may have noticed we hooked up a live tweeting system here. So we're going to use the hashtag #IAST, that's IAST. That stands for Interactive Application Security Testing. And that's Gartner's name for what we do, what this kind of testing is, called IAST. So don't be shy. Please go ahead and tweet during the talk if you want. Ask your questions or comments. We encourage it. So you guys have probably heard of Anonymous and LulzSec, but what interests me about these groups, and you may not have heard in the news because it doesn't get reported much, is that these groups are chaotic, they're leaderless, but I think what's interesting to me is that they're actually set out to do good. That's, their driving motivation, I believe, is for good. And let me tell you a little story. So this is GeoHot, George Hotz. He's the guy who jailbroke the PlayStation. He also did a jailbreak on the iPhone. Absolutely brilliant guy, despite the haircut. And when he did that, when he broke the PlayStation, Sony's lawyers came after him, and it pissed off the internet. So these groups, Anonymous and LulzSec, they started attacking Sony to get back and to sort of defend this guy because they were sort of defending the freedom to use computers in the way that you want. And that next year, Sony got hacked 19 times, mostly with SQL injection. They took down the PlayStation network. They caused a lot of damage. It cost at least a minimum of $119 million. But there's a lot of difficulty measuring the cost, but it's probably a lot more. So what's going on here? You don't have to be a big financial organization to get hacked. This is not about credit cards and money. This is, I think, about, if you do something to piss off the internet, they'll target you. And a number of companies, like we mentioned Sony, but Fox and Nintendo and PBS all found out the hard way. So I actually agree with Anonymous in one way. The internet is way less secure than it needs to be. So Arshan and I have done a ton of penetration testing and code review over the last 10 years. Aspect looks at roughly 5 million lines of code every month for security holes. And these are our numbers from last year. You can see the different categories here and the number of vulnerabilities we found. On average, we uncovered 23.2 vulnerabilities in applications that are probably just like yours, written by some very smart developers. So these numbers are incredibly disappointing to me, actually. 10 years ago, I wrote the OWASP Top 10. And when I wrote it, I had this idea that in a few years, we'd start to get on top of those problems, and we could move on to like the next 10, and so on. And we'd improve the industry, and we'd have this floor that raised. But unfortunately, it's 10 years later, and we're still finding exactly the same kinds of flaws in the same kinds of apps. And in fact, I think it's getting a lot worse in some ways that we'll talk about. If you're still skeptical, check out the Verizon data breach investigation report. These guys go in after breaches and investigate all the details of exactly what happened. It's a very well-regarded study. And what they found last year's study is that of the 381 breaches that they investigated, only 5 of them were patchable, meaning that they could have been stopped if the organization had been up to date on all their patches. So that means, that's an interesting finding, right? That means that even if you had the best firewalls, best IDSs, the best patch management, the best hardening, the best virus scanning in the world, 376 times out of 381, you still get hacked. And what this means is that you have to do your security protections in your code. So what's the problem? And I wrestle with this a lot. I think something's going wrong. So who here loves working with security folks? Right, well, so security hasn't always been great to work with. And I think, sort of in a nutshell, like security hasn't figured out how to work with real software development projects very well. Like we're not compatible in some way. So we end up trying to force security on projects, and it's not right. We desperately need an automated way to find security holes accurately and usefully so that you guys can integrate into your development processes and solve this as part of the normal development process. So to give you an idea, I mean, it sounds like an easy thing, right? Well, we'll write a tool, we'll scan for SQL injection or something, and we'll fix them. Unfortunately, it turns out to be really pretty difficult. And so just as by way of analogy, what I wanted to put out for you is, imagine that someone asked you to write a program that would find all the loopholes in the US tax code. It's about that level of complexity to find vulnerabilities in a 3 million line of code app. The tax code is about 3.4 million lines of tax code. So it's an interesting, challenging problem. Let's look at what it might take to build a tool like that. So first we've got to look at the tools that are out there. So there's really two classes of existing tools, static tools and dynamic tools. Static tools look at source code, and they scan through the source code, they parse it, they build a model, and they analyze the model for vulnerabilities. The problem is that the static tools don't have access to the environment or the runtime data or a lot of other details about the libraries and the frameworks that you're using. And so they make a lot of mistakes. And they don't get particularly good coverage. Dynamic tools work a little differently. They sort of scan your running application. And a colleague of mine described it this way. He said, doing dynamic scanning is like trying to find problems in the water heater by staring through the shower head. And it's a little bit like that. You only really light up that front part of the application, most of the UI. You don't get good access to the back end stuff, the details. And it's all that dark code where a lot of vulnerabilities live. So we need an approach that will light up the whole app, right? That'll illuminate all the code so that we can find vulnerabilities. So let's look at what a vulnerability actually looks like in order to help us design this tool that we're going to build to find these vulnerabilities. This is the SQL injection example from OWASP. And it's pretty standard here. You see that the username and password are getting concatenated into a query, and then that gets sent to the SQL database in that statement.execute. And if the attacker sends in bad values for either username or password, then they'll be able to inject and change the meaning of that query. But this isn't enough to decide whether this is a vulnerability or not. The problem is you don't know where that username and password came from. It might have come from a request. It might have come from something else. You don't know. And you don't know the path that it followed. Did it go through validation? Did it go through some kind of encoding? And did it get manipulated in some way? In order to understand the vulnerability, you've got to see that whole path through the application, right? So I think of a vulnerability as a series of events, not just a point, not like one line of code. It's better to think of a vulnerability as a sort of a path through your application. And so here's an example where that first circle up at the top left, think of that as like request.getParameter. And then maybe this thing goes through some string appends and some validation. Maybe it gets put into a data bean. Maybe it gets stored in the session. Maybe it gets serialized and rehydrated. And eventually, there's a vulnerability. But you have to see the whole path. And in order to really determine whether it's a vulnerability, you need to know whether it's, you need to have view into the control flow and the data flow and the runtime data. And then you can decide very accurately whether it's a vulnerability. So let's stretch that line out. Let's just take that complicated path and put it into a straight line and think of just a straight line series of events. Because it makes it a little easier to think about a vulnerability when we look at it. So here's a full vulnerability trace. It starts at what we call a source. That's where we get a parameter out of the HTTP request. And now we've got a piece of tainted data or untrusted data. And you can see then it flows through the application. It might go through some data flow operations and some control operations, like here's a regex, and on down until eventually we hit what we call a trigger. In this case, it's the SQL exec. And you can see our untrusted data flowed through the application. Now, if we can see this, then we have super good confidence that this is a real vulnerability, because we know exactly this. But there's a problem. Super complicated applications make this really tricky. This is part of an HTTP request that was generated by Google Web Toolkit. And it's a serialized data structure. It's actually pretty complicated. Some of these fields refer to other fields. So you can't just edit this. We used to have tools like WebScarab from OWASP, where we could edit an HTTP request and do some testing. But with these kind of data structures, we can't do that anymore. You can't just edit this. Now you need an actual sort of a plugin to parse this and change it and then resubmit it. So penetration testing, this has made penetration testing considerably harder. And that's not the only problem. So here's some of the challenges. Almost every advance in software development recently has made it much more difficult to do security work. So on the static analysis side, just the size and complexity of apps has made things much harder. The use of lots of libraries and frameworks has made static analysis much more difficult because you have to teach them about that. Using point cuts, building custom security controls, and doing 100 pushes to prod a day makes our work much, much more difficult. And on the dynamic side, it's even worse. So we're seeing applications now that send lots of requests really fast. We can't intercept them and modify them. We're seeing web services and other types of data structures that have complex authentication processes that we can't figure out. Seen a lot of serialized objects. And lately, we've even seen mobile apps and HTML5 WebSocket apps that there are no tools for. In fact, there are no tools on the market that will solve any of these challenges. We're currently at about 2002 web technology level in our ability to test stuff. And the apps are rapidly advancing past that. So I look at all this, and I look at all the trends, and I get really frustrated, and I just hit bottom. So I give up.
Hello. Good? So we didn't really give up. We weren't happy with the automation that existed because we've been working in this space for a long time, trying to use the automation that's there, and it's just it wasn't great for a lot of reasons. So a smarter person probably would have picked a much easier problem to work on, but we did what we did. So a lot of biotech companies are figuring out that the best way to figure out what's going on in the human body is to put a sensor into it and measure it. And so that's what we see here. This is a sensor the size of a grain of rice. It gets implanted into your arm, and then you have this external RFID reader that reads that sensor and monitors your glucose levels. So people with diabetes don't have to do the finger prick thing all the time. So this is the future, and this whole conference is about making Java the future, right? And so what if we could have this same kind of setup for the JVM? What if the JVM had a bunch of sensors in it that we could monitor from the outside, and the JVM could report its own security weaknesses or report weaknesses in the apps that run on the JVM before they ever reach the field? So if we want to capture all the details, all the events that could lead to vulnerabilities, then then if we could take those events and use the application normally, right? Install sensors into those events that Jeff mentioned, and then feed them all into a central brain or a rules engine. It's possible that we could use that rules engine that's getting feeds from all these sensors to detect vulnerable combinations of those sensor events. So imagine a untrusted piece of data gets retrieved by the application, and then later that same value is used in a SQL call. Well, that's pretty easy, right? That's a SQL injection vulnerability. So that's very easy to model when we think like that. And so that's the future that we want to get to. So, if we could just, let's imagine what those sensors that we would install look like. So this is a fake Tomcat class, that implements the servlet request spec. So, what if we could just, in the get parameter call, which retrieves a piece of untrusted data from the user, weave in a little sensor that has a callback to some brain that says track this object. This object is untrusted. And then later, deep within the JDBC library, we do the same thing in execute query. This is the trigger that Jeff talked about. This is the end event. Before we execute the query, we check if the object is tracked. And then if it is tracked, we've got that source to sink model now, right? We have the sensor when the data came in, and we have the sensor when it's used in a dangerous API call. And so we should be able to detect security vulnerabilities this way. So how are we going to weave those sensors in? Instrumentation is the general idea that you're adding code to a binary runtime. So how are we going to do that? Well, you could add calls to source code, but this doesn't help the problem of all the developers out there adding sensors to their own code. That's probably not going to work for scalability reasons. Plus, a lot of the events don't happen in your code, right? When you get a request parameter, that could be deep in the Spring stack. Or when you're executing a SQL call, that could be deep in the Hibernate or whatever your ORM is. So in AOP is the same issue. The point cuts are not where your code is. And again, if you had to write point cuts for everything, it's not going to scale to every developer in the world. So technically, if you wanted to, you could bootstrap Java classes, or you could bootstrap library classes, or you could just modify all the classes in rt.jar or whatever. But this is really invasive, and nobody's going to want to do that. So, of course, we're going to end up at the Java Instrumentation API. So the Java Instrumentation API is awesome. A couple years ago, Jeff was doing research in kind of throwing away OS-level rootkits, because there's a lot of stuff there going on, and working to build a rootkit into a Java application. And I was doing some work on hacking Java applets. And so both of us were using the Instrumentation API for those distinct research projects, and it wasn't until we were done with those that we thought, why don't we use these to try to solve this problem? So the Java Instrumentation API is awesome. It's like one of my favorite things about the Java environment. It's pretty simple. You package your code into a jar, and then you do Java agent equals your jar. And then your code from that jar gets executed before the main class of whatever the program is. So your pre-main method that you override is given everything you need to change classes. You can change the behavior of classes. You can add code to methods. You can't add members or take away members, and you can't add or remove methods. And if anybody here is from the Java Instrumentation team, we'd really love to be able to add members. So there's two ways of actually changing classes. The first way is called using transformers, and that's what a lot of framework people tend to use. So that means you're just another step in the creation of a class. When a class gets loaded, you register a transformer with a JVM, and the JVM comes to you every time a class gets loaded and says, hey, here's some bytecode, do it, whatever you want to do with it, and give me the result. So that's great, because you don't miss any events when you do it like that. Before the first time that the class is executed, you can change the method behavior. But then there's another way of doing it with an API called redefine classes, where you can just say, here's the class, and here's the bytecode. This is how it works now. And you can tell the JVM, it'll change the bytecode, and it'll do it kind of immediately. So you can be inline with the class loader, or you can just asynchronously just call for it. So, like I said, we can change method behavior. And so it took us about a year of building test cases and working out some bugs before we got to a point where we said, holy crap, we can actually track data in the JVM. So as you can see in these test cases, these are relatively contrived scenarios where we're purposely kind of make it difficult to track a piece of data as it moves throughout the function. So we base64 encode the data, we substring the data, we replace all, and we do a bunch of weird stuff to try to lose the tracking, but we're still able to do it. So like I said, it took us about a year until we got to this really happy place where, wow, data comes in, we can track it as it goes through its normal operations, and then we can see it when it gets used in dangerous stuff. So we got a lot of tweet from Larry Wall. Says, nice work, guys. You just reinvented Tate mode. Well, Larry, it's a bit snarky, but you're actually incorrect, but you're on the right track. So Tate mode, introduced in Perl, maybe somewhere else before that, was all about just tagging input data that came from the user, and so if it ever got to a sensitive API, it would just blow up. But as the commercial space for the tools, those guys still can't figure out, treating data as either untrusted or trusted is not enough. It's far too binary. The quickest way to lose a developer's trust is to report problems in security tools that aren't problems. So we need to think a little bit harder about that. So this is bird ringing. I'm not sure why people do this, but the point is when a bird comes into these set up cages in this ecosystem, you get the bird, you take the tags off of the bird, and you read what tags he's already on him, and then you put your own new tags on. So you can say, this bird's name was Jim, he appeared hungry at this time, he looks a little sick, or whatever. So you can kind of keep track of the bird as it flows through these gates in your ecosystem, in your forest. So we can do the same thing in the JVM with data. You see, when data comes into the JVM, it's not just like, there's a variable here and it bounces through the system by itself. When a piece of data comes in, it usually gets substringed and replace all, and each one of those things, each one of those operations creates a new string because strings are immutable. So you end up with like one piece of data shattering into a million different strings. So being able to track all those strings is super important. And so the tagging kind of helps us keep track of what is happening to the individual fragments of that original data as it moves through the system. So here's an example of that. So this is the trace that Jeff talked about, right? The series of events. So our sensors have sent these events to the central rule engine, the brain, and the brain has correlated them all and said, okay, well, this path now looks like it might be a vulnerability, so let's look at it. So the first thing that we see is the first tag that comes in is user input, because the data came from a request.get parameter call. And then the data is appended to something, and then the data goes through a regex, and so we say, well, that can have limited characters. We tag it with limited characters because it went through this tough regex. Right, so now we can be a little smarter with our decisions about that data, and is it really being used dangerously because it's already been validated. So then there's a replace all, and then perhaps most importantly for this slide is the data went through an escape for SQL method, which makes it not possible to sneak a SQL injection attack through this API. So that's why we tag it with escaped. So now the trigger is going to look at that. So normally this would fire off a finding and say we found a SQL injection vulnerability, but because it's gone through this API, although the string itself is tracked now because it has part of it is untrusted, it's got the tag that says escaped, so it's not going to be reported as a vulnerability. So another neat thing we can do, really not sure we really invest in this feature, like it's far beyond what's necessary to prove problems, but we actually thought it'd be cool to highlight which individual bits of a string are the tainted bits or the untrusted bits. So when the parameter first comes in, we just have the 3 letters FOO, and then we do some string manipulation. And as you can see, as it goes through the flows, as it goes through the propagation events, we can see that we're only keeping track of the pieces that are actually tainted. So then if I can hand this to a developer now, and he sees the SQL call, it's super easy for him or her to understand what happened here. They see the original piece of data, they see how it was mucked with by the JVM and the libraries, etc. And then they can see that it was used in a SQL call. So it's easy to prove. So if you've ever had the unpleasant experience of working with a static analysis tool or dynamic analysis tool, you've probably you've run into these problems where if you're given a static analysis result where they say you have SQL injection on this line, and you fix it, it's really hard to actually reproduce the issue because you don't know how to execute that code path, right? Because the static analysis tools, they simulate the runtime execution of your code. But they don't really do it, so they don't know how, really the starting point to get to that. They don't know whether you came through the web or you came through a web service, or they don't know what the starting point is, so they just tell you, here's the line, good luck. So it's difficult to reproduce and test your fix and make sure your fix didn't break anything because of that. So then if you ever have a dynamic scan, you kind of have the reverse problem, right? They give you a URL that they were able to execute some blind SQL injection through, but then you don't know where in the code that matches up. And if it's a SQL injection problem, then you don't know, I mean, it could be in several queries, and if that's deep within your ORM, I mean, who knows, how to figure out where the problem actually is. So I keep using SQL injection here because I think everybody's super familiar with that, but I want to encourage you to think bigger, right? There's a ton of vulnerabilities that you can have in your web apps, but that one really seems to connect with people. So with an IS technology, like contrast, which is the one that we're talking about today, you can actually get both of those things, right? Because at any time, the contrast brain can create a stack trace and figure out how we got to where we are, right? So you can get the lines of code that cause this event to occur. And also because contrast is in the JVM, it can look in a thread local and say, what's the current HTTP request? So what we have here on the left is the lines of code. I know it's pretty small, probably hard to read, but it shows you the lines of code where these events are happening. We got a parameter, user, and the value is shemp, and then it goes through some stuff, and there's another parameter that's retrieved, public share. And then at the end, those two pieces of data are written to the browser without any kind of encoding or sanitization or anything, and that's what a cross-site scripting vulnerability looks like. So we give you the lines of code here, and we give you the runtime data so that it's easy to understand and reproduce. Here's the stuff here. And then, like I said before, we don't have the weakness of choosing one or the other. We can actually see both because we're in the JVM. So this is the HTTP request that caused the cross-site scripting issue to occur. And as you can see here, shemp and public share are in there. So there's even this little button here, replay request in window, where you can just click the button and it'll reissue that HTTP request in your browser for you to, if you want to further exploit it or you want to just exercise that code path, you can do that quite easily. So after all this testing and I built this great UI, and I was really happy with it. Jeff was still skeptical. So let's see what he says.
Okay, so this is really exciting, right? We went from a theoretical approach, like we thought we could pull some really cool security information out of the running application, and we implemented it, used Java Instrumentation API to get that data out, and then we made it work, right? So now we've got the real traces coming out of real live applications, and you don't have to do any real security testing to get this to happen, right? You just use the apps, sensors fire, and you get this data out. But there are still some questions around, how accurate is this thing, and what kind of coverage are we really getting? So Aspect does some work for the NSA. We're headquartered in Columbia, Maryland, and we're right down the street from Fort Meade. And so we know there's a group up there called the Center for Assured Software. And their whole mission in life is to help government organizations use security tools. And they put together a test suite for static analysis tools. They built 13,800 test cases to test static analysis tools to see if they really work. And each test case has a true vulnerability and then a number of false alarms to try to trick the tool. And in order to pass the test case, you have to find the flaw and not go for the false alarms, right? So the existing static analysis tools don't do very well against. So the NSA's published their results. You can download the paper about this. But all together, they took all the major static analysis tools on the market. And together, all those tools only passed 15% of this test suite. So they weren't doing very well. But we decided, hey, you know what we could do? We could just run those test cases with contrast installed and then look at the results to see how we did. And so we did that. We passed 74% of the test cases with no false alarms at all. So we feel like we've done something really interesting here. Like we feel like we've made a real advance over the state of the art. And when we looked at it, we thought, hey, let's filter out just those sort of OWASP top 10 kinds of security tests, just the ones like the web flaws that we typically deal with. And from those, we're passing 99% of that. Now, that doesn't mean contrast is perfect. Okay, I want to tell you about this test suite, right? So the test suite, it's pretty simple. It's not like real code, right? All those 13,000 test cases, they don't look like real code. They're actually, they sort of they took all the sources and all the sinks and kind of automatically cross-multiplied them to generate those test cases. So it's surprising to me that the static analysis tools didn't do better against this. But still, I think there's good reason to believe that we're onto something here, right? We've got a new technique, and more information is leading us to make better findings. So we also wanted to look at, sort of what's the range of vulnerabilities that we can find. I know there's a lot of companies out there that claim that they can solve the OWASP top 10, right? Run this tool, you'll be compliant with the OWASP top 10. And it's always been really frustrating to me because I know what's in the OWASP top 10. We feel like we're doing something, we're getting really, actually pretty good coverage over the OWASP top 10. We're not finding one instance of one vulnerability in one of these categories. We're actually sort of covering the whole category. Now, we can't find everything. There are still some things that are outside the scope of IAST, right? Things about the environment, like if you're going through a web app firewall or something that's protecting your app, like we don't have access to that information, so we can't make judgments based on that. But we think we're getting good coverage over the OWASP top 10 and then a bunch of other things as well. I wanted to talk about a couple in particular here. I wanted to show you our rule set for, this is our rule for strong encryption. Now this is, it's a simple rule the way we write it. We have a simple XML format, and we want to build a community around this. I'll talk a little more about that. But we want the community to work on these rules and making it open. But this is our rule for using a bad crypto algorithm. And you can see here, it's the call to cipher.getInstance here. And we look at the first parameter, which is this data. And this says it has to be either triple DES or AES. Okay? So now this is an interesting rule that neither static analysis or dynamic analysis can find. Right? Static analysis can't find this because it's a runtime parameter. That triple DES value might have come out of a properties file or out of a config XML or a database or something. And so it doesn't exist in the static app. So static analysis can't find it. Dynamic analysis can't find this because it's the showerhead problem, right? You're stuck looking at the front door when this choice of algorithm is probably way deep in the bowels of your application somewhere. So we can do these interesting rules that I think would be very difficult in other ways. Our rules drive two things, actually. The rules drive where to put the sensors in the application. So all you have to do is when you add a rule, the engine will automatically know where to put the sensors to enforce that rule. So it's all rule driven. And the other thing is that the rules also have the vulnerabilities in them. So it tells you the pattern to look for in those events. Here's our rule for SQL injection. This also very simple. In this case, we're looking at statement.execute call. And what this says is that the first parameter, if it's tracked, meaning it contains any untrusted data within it somewhere, then, and it hasn't gone through the escape for SQL control, then it's a vulnerability, and we need to report it. So it's a very powerful way of specifying this. This will handle all the different database drivers that are out there. We know to instrument anything that implements SQL statement.execute. So we'll find all of those. So I think we're really just scratching the surface here of what we can do with IAST security analysis. There's a ton of information inside the JVM that we can now access because of the Java Instrumentation API. And we can make security a lot better, a lot more compatible for real developers. I wanted to point out one other thing that we thought of that's a cool feature that we can do. So last year, or early this year actually, we did a study, I guess it was January. We did a study where we looked at the libraries that people are downloading and using in their applications. Now, is everybody here sure that their libraries are completely up to date? It's probably not. And we've got evidence to prove it. So we did a study we partnered with Sonotype, and we went and asked them for some data about downloads. We looked at 113 million downloads from 60,000 different companies of the top 31 Java libraries. Actually, it was 20 of the top libraries and frameworks, and then we looked at 11 security-focused libraries because we were interested in that. And what we found was a little disturbing. So over 25% of that 113 million downloads, that's 29 million downloads, were libraries that had known vulnerabilities. So that means a researcher out there had published a vulnerability against that version of the library, and no one did anything about it, right? You're still downloading old vulnerable versions of Struts 128 or some old version of Spring. Some of these vulnerabilities are devastating. Some of them, if you're just using the library, then you're pretty much vulnerable to complete takeover. But yeah, there's huge amounts of downloads of these. If you look at there, it says GWT had vulnerabilities, and there were over 17 million downloads of the vulnerable version of GWT, which exposes your site. So we thought, hey, that's an interesting statistic, right? There's probably a lot of vulnerable apps out there that have downloaded this code and used it. There's a paper about this if you're interested in more details on this. But we thought, hey, we can look at what libraries get loaded at runtime and get information about them. So with our IAST engine, it plugs in, it watches libraries get loaded. We do a SHA-1 hash of the library itself, and then we look it up in our database, and we figure out what version it is, and we report back to you, hey, you're using a version from 2005. So I think we got the Commons library there from 2005. The latest version was in 2010, and it's several major versions out of date, and we give you a letter grade on that stuff. So I think it's an interesting way to get good information out of the JVM about the security of your applications. So when I zoom back and I think about this approach, I think about how it might change our industry and how it might change software development. I really started thinking about more like New Relic and App Dynamics, the way their performance tools work. You just plug in their engine, you run your app as usual, and you get this great dashboard that says where all your performance problems are. Well, security can work that way too. We can get away from the annual pen test with the crappy PDF report that's out of date the second it hits paper. We can move away from that. We can have an environment where you guys get real results from your real running app, continuously, real-time, and automated without involving a lot of security experts doing a lot of crazy penetration testing. So we're excited. I think Arshan and I, neither of us want to find any more SQL injection or cross-site scripting. We're done with that. And so we want to get past that. I think we'd rather work on really hard security problems, things like access control and identity systems that are actually really complicated and really deserve some attention. But this is the future that we're trying to look at. I did mention we're trying to build a community platform. Arshan and I are both heavy contributors to OWASP. We've both run a number of open source projects and libraries. And so we want to try to build community around this idea of automated security testing within a running application. So we've got our open rule language. We've got a REST API that you can pull this information back into your bug tracking system and so on. So we're actually committed to openness on this, so we really want to encourage that. I think we're really looking to advance the state of the art here and get the internet more secure. So if you have any questions, please stop by. We've got a booth set up at booth 5205. You can try it if you want. You can sign up. I got a QR code if you want to go to contrastsecurity.com. You can create an account and try it for yourself for free. If you come by the booth, there's a white paper, there's typical stuff. But if you sign up for an account, we'll put you in a drawing for a MacBook Air. And I'm obligated to point out that we are hiring. So this is an interesting project that we think deserves a lot of good attention. So thanks for your time. I'd love to open it up to questions if anybody has any thoughts or comments. Yeah?
What's the performance hit of terminal instrumentation?
Yes, it's an excellent question. It's a little tough to measure because it depends on your application a little bit. If you're doing huge numbers of crazy string operations, the performance is a little more. But in general, we've seen 2 or 3% performance hit on round trip time. So it's not terrible. We actually won a contract from Air Force Rome Labs to improve performance, and it was terrible. Now it's much better because we did some amazing things to make this, to optimize this. We put a lot of work into it. We could talk about that offline, but we did a lot of cool things to make it much, much faster. Yeah.
So, is there a way to turn off the instrumentation in production? You only run it in your development?
Oh, that's a great question. So, where to run the engine is an awesome question, right? So you could run it in production, but we're not really encouraging that. I think most people will want to run it in dev or test environments. So, it depends on your setup, right? There may be some organizations that need to run it in product because they don't have a dev or test, right? They just bought a product and they need to run it there. But there's some cool things that happen if you run it in dev or test. If you've got a bunch of developers and they all run with this, then when they get the results, they all come together in the team server, and you can filter down to the results that are just applicable to the code you're looking at. So it's unlike the PDF model where you get everybody's vulnerabilities. You could just see a view of the results that, just what you hit in your testing cases. But I don't think most folks would just want to run it in dev and test. And maybe you only put it in, a couple of your test servers. Or if you've got a load balanced environment, maybe you just put it on one of the instances. So there's a lot of different options here. But the engine just works. You can drop it in on as many instances of the app as you want, and they all report together to pull together that. Which brings me to another point that I think is kind of cool. A lot of organizations struggle to know what apps they have out there. I think Citibank has, or JPMC has like 15,000 applications, right? So they might not know. If you put an agent like this on each of your app servers, it can just report back not only what apps you have, but a bunch of metadata about each app, right? How big is it? What libraries is it using? What backend connections does it make? What databases is it talking to? So there's, you can pull together an application portfolio real time that's really accurate. So, good question. Yeah. We do almost all of our work is with banks. Yeah, large financials.
And typically, when the tool is being used, who's reviewing the information? Is it typically developers, or is it the people that are actually developing the application, or is it the security groups that are?
Yeah, it's an excellent question, and I think it's going to change. So currently, most financials have a small application security team, and then lots of development groups all over the place. And the app security team, they go visiting, right? They visit your project and you go through a review and then you pass and you fix some holes and then you go to the next one and they're getting overwhelmed. The volume is just ridiculous. I mean, one app has turned into 5, right? We got, used to get just one servlet-based app to test, and now you've got that, plus you've got the mobile apps, you got an Android one and iPhone one, you got the web service interface, you got the rich HTML5 thing. So it gets really complicated for these teams. They're getting overwhelmed for all the reasons that I mentioned. And so I think it's going to change. I want them to do this, right? Drop in an agent on those apps, pull together a dashboard. Maybe the security team helps review that, or maybe the development team can just take this information and fix the problems, and that small security team can focus on more strategic things. Let's focus on getting a really good implementation of a validation API out to all the development teams. Like, they can focus on interesting, hard problems and not just chasing XSS all the time. So I think it's going to change. It has to change, actually, because the path we're on just doesn't scale at all. But that's a different talk. Yeah.
So, I have questions about how it works. If you drop in an agent on an app, what does that mean?
Yeah, so remember Arshan said to launch the agent, you just add that -Java agent flag to when you launch the VM. So when you do this in an app server, frequently it's just an environment variable that you set, like Java ops, and you set -Java agent equals contrast.jar. And that's enough. Then you just launch your app server as normal, you run your app, you use it as normal, you don't have to do anything different. But under the hood, contrast is watching. And if it sees a vulnerability, it'll just report that out to the dashboard. So it really is just that easy. I encourage you to stop by the booth, and you'll get a feel for it, because it really is just that easy. You can install it in 30 seconds.
So it's the same JVM as your application?
Exact same JVM. Yep.
And I think an interesting tip into that, if this works,
Yep.
is that just on a whim, we've been focusing on Java EE, but then we ran it on a Scala app, and it just worked. Like we didn't do anything. Like because it's all the JVM, right? It's all bytecode, and what's amazing is all these languages are moving to the JVM, and we want to be able to support all of them, and it isn't turning out to be much work to do that because under the hood, it's all the same bytecode. So Scala people should take note.
Yeah.
So what about environment that is internal to the corporation?
I think so. It's a good question. So a lot of organizations, their initial sort of knee-jerk reaction is, we need to do security testing on all our external-facing apps, right? But if you think about it, the internal apps are often the ones that safeguard the most sensitive assets, the financials, the intellectual property, all the really sensitive stuff is internal apps. And so I would say at least half of the work that we do is on internal apps for organizations already. I absolutely think this is the right thing to do for internal apps, and external apps. It really, I think it's a bad strategy to focus on just external-facing apps, especially when every one of you has a browser that connects to the internet and your intranet at the same time. Well, that's like a zillion gateways between the bad guys and your internal apps, right? So one of them is going to get knocked over, and then you've got a problem. Yeah?
So I have 10 JVMs running on one server. So I have to do what listings might be on those 10 JVMs.
Yeah, I mean, yeah, you'd install it. However many app servers you're running on that server, you would put this in all of them. You install it once in an app server, though. If you have 10 apps running on the app server, you just have to put it in once, right?
10 different JVMs.
Yeah, one per JVM. So you just enable it in your launch configuration for. I don't know. I haven't done it, but it's probably the same. It's probably the same 2% per JVM. Yeah.
I mean, I think it should go. It's funny. All the business people we talk to, they're like, "Yeah, let's run it in prod," and we're like, we want it to run in dev and test because the performance impact is not as important there, and you get the vulnerabilities earlier. Like, why would you wait until you're already exploitable to find the vulnerabilities? When we found them a month earlier. And so if you had 10 JVMs on one server, first of all, I'd like to buy that hardware. And then, I'd probably want to focus on, maybe, think about what your threats are and maybe just strategically place the agent on whatever JVM you think is facing the most external or facing the biggest threat.
Yeah.
Is your agent geared towards web apps or other types of apps?
It's currently, the rule set is geared towards web apps, right? But the agent itself, you could actually install it in anything that runs on the JVM, but you might have to create different rules for whatever kind of security attack you wanted to try to detect, security vulnerability.
So did you have something in mind that?
Yeah, we have JSR 289 stack set.
Mm-hmm.
Stack running on Java.
Cool. So the exercise would be to do some threat modeling and think about what kinds of vulnerabilities are in that environment, and then design some rules to make sure that your code doesn't have any of those. Right. And you saw the rules. It's not tremendously difficult to figure out.
What's interesting is that probably half of the rules are the half that you need, like the things like SQL injection, because a lot of those times the threats on the server don't change, but maybe how the data gets into the system and how we recognize what untrusted data is coming from that stack. That's just the part you need to figure out, and then everything else will just work magically.
So I got to share a little story real quick. My son is 14. He's learning he wants to get Java certified, and he's really mad that I'm here because he wanted to attend. But I asked him to try it. I was just like, he hadn't seen it at all. I just said, no, go to contrastsecurity.com, create an account, download the engine, put it in your little web app. He built a little web app for his school, and try it. And so about half an hour later, he came back and he said, yeah, Daddy, I had some vulnerabilities. He found 6 cross-site scripting holes and 2 SQL injection holes, and he fixed them with the information available in half an hour and came back. So I was just psyched about that. Sorry, so there's a couple other questions. Yeah?
The question is regarding the rules. Who's responsible to define them? Is it something that you provide with the libraries, or you're expecting the application itself to define it, or both?
So we have a set of default rules that the contrast comes with, and it's pretty extensive. It covers all those OWASP top 10 ones that I looked at. But maybe you want to track credit card numbers through to make sure that no credit card numbers ever end up in any log files, right? So you could define sources. You could say, hey, these 3 APIs produce credit card numbers, right? You get it out of the database or whatever. And then Contrast will track those credit cards through the application, and you could define triggers for credit cards. You could say all the log interfaces should never get credit card numbers. And so if you set up those sources and those triggers, then it'll just work, and you'll get findings about credit card numbers. Yeah.
Those rules, are those housed in your servers, or are they housed in-house?
They're centralized in the server so that you can manage them across all your apps. Like if you wanted to say, hey, we only use AES. Okay, great. We push that rule out to everybody. But they get downloaded to the engine. When the engine starts up, it reaches back to the server and pulls down the latest rules. So that way you can manage them across your whole organization, but they load locally.
So as we make rule updates and stuff, the next time your JVM starts up, it'll just get the latest rules, and you don't have to think about it.
And what the server where this you said something about the server.
Yeah, so we have the engine, which is actually really small. The engine is the agent jar file. It's less than a megabyte, and it sends the findings out to a standard sort of server that it collects all the findings and gives you a dashboard and all that kind of stuff.
That server is yours or in-house?
Yeah, it's ours.
Okay.
Yeah, but yeah, you can. Yeah, exactly.
How many of the frameworks that you mentioned actually use your tool in Perception?
How many frameworks that I mentioned?
A bunch of the frameworks.
Oh, these libraries, these things. So we've used it on a bunch of these. I don't have the exact list, but we've used it on applications that use a lot of these different frameworks. The harder thing for us is that we're in the process of vetting it out on different app servers. Generally it just works, but some app servers do weird things with OSGI and class loading and stuff that we have to work around. So we're in the process of certifying it for a bunch of different app servers. But it's good on Glassfish, JBoss, Tomcat, and some others. I don't have the exact list here. We're working to certify it on WebSphere. Anybody who wants to help us certify it on WebSphere, we'd love some help, because we need an environment to test it in. We could do it right now if you've got it on your laptop. Any other questions?
I installed my JVM dash agent. So how does that actually, where the report goes? You say it sends it back to your engine. How do I get the report? Is it dashboard?
Yeah,
So there's a SaaS piece that runs in a secure data center, and you log into your dashboard there, just like the way that App Dynamics or New Relic work. All the data goes there over a secure connection. It's all super mutually authenticated and so on. And then you just log in and you get your dashboard live.
So all that's running on the engine.
Yeah. Well, I hope you guys stop by the booth and check it out. It's fun to play with. I mean, it really is. You just load it, play around with your app for a little while, and then you go and you've got vulnerabilities there. So please come check it out. It's in the Hilton, and it's booth 5205.
5205. We got one more question.
Oh yeah, please.
This engine, it's running at JVM, but is it clustered? It might be the request flow. You can start in one
Right.
So do you have the ability to trace a request if it spans several object events? Is it just, I mean,
Yeah, I see what you're saying.
Yeah.
So we do have some support for it's not clustered, first of all, but we try to put in some magic, like if you have the right, if there's a certain entity annotation on your class, if it goes through a setter, then we'll always know that the getter returns untrusted data. So we do some magic to try to detect that kind of stuff, but it's definitely not complete, I'd say.
but are you planning to go there?
I don't know. We haven't talked about it actually.
Yeah, we'll have to see how much that's really a problem for real apps.
We love feedback. So
Excellent. Thanks, everyone.
thank you.